All right, today we're diving into a project called JetPascal, and it's more than just code. It's a story. It's about how to slay a monster that lives deep inside so much of our older software. You know, that monster that makes things slow, fragile, and just almost impossible to improve. JetPascal gives us a radically new blueprint for how to build things better.
So it really all starts with this one question. I mean, if you've ever worked on a big old code base, you know the feeling, right? You want to add one tiny feature, but you're terrified the whole thing is just going to crumble. So why does that happen? Well, to really get why the JetPascal solution is so cool, we've got to meet the villain of our story. And that villain, hiding deep inside a lot of compilers, actually has a name. It's what's known as a design anti-pattern, and they call it the God object.
So what on earth is a God object? Okay, imagine one single chunk of code that's responsible for, well, for everything. It handles every single feature. It knows about every complex state. And over the years, it just grows and grows into this tangled, monstrous beast that nobody even dares to touch. It becomes this huge bottleneck that stops any real progress.
Now, in older Pascal compilers, this isn't just some abstract idea. We're literally talking about a single class with more than 80 different functions and thousands of lines of code all snarled together. Trying to add a new feature isn't just coding. It's like performing open-heart surgery on the system where one wrong move and the whole thing flatlines.
So how in the world do you slay a God object? Well, JetPascal's answer is, honestly, it's just beautiful. Instead of having one giant thing that does everything, this architecture uses hundreds of tiny smart objects that each do one thing, and they do it perfectly.
And you can really see the difference right here. On the left, that's the tangled mess, the God object. But on the right, that's the JetPascal way. Every single piece of the language, a for loop, a variable assignment, you name it, gets its very own little wrapper class. It is a complete game changer for just being able to manage the code.
And the power of this design is just staggering. The central brain of the whole system, the part that directs all the traffic, is only about 150 lines of code. But here's the really mind-blowing part. It never has to get any bigger. It doesn't matter how many new features you add to the language.
So how does it actually work? It's this really clean four-step process. First, the Pascal code gets read into a kind of tree structure. Then, that tiny little dispatcher we talked about just hands off each piece of the tree to its own special wrapper. From there, each wrapper independently spits out the C++ code it's responsible for. And finally, the Zig build system takes all that C++ and compiles it into a super fast program. It's simple, and it's incredibly effective.
Okay, an elegant design is one thing, but is it fast? Well, this is where the story gets even more interesting. By translating old Pascal into modern C++, JetPascal unlocks a whole new universe of speed.
3.3x. Just let that sink in for a second. In one key benchmark, that's how much faster it was than a native, commercially compiled app. That is a gigantic difference.
And this wasn't just a fluke either. As you can see from these benchmarks, we're seeing huge speedups pretty much everywhere. String stuff is over 3 times faster. Heavy-duty math is almost twice as fast. And even just basic array work gets a really nice boost.
So where is all this speed coming from? Well, it's really a combo of 3 things. First, it gets to use LLVM, which is this world-class compiler technology that powers giants like Apple's Swift. Second, it uses the super optimized C++ standard library. And third, it just avoids a lot of the performance overhead that slows down older Pascal systems. You kind of get the best of all worlds.
Now, performance is amazing, but for developers, for the people who actually have to maintain this code, this next part is maybe even more revolutionary. Remember how scary it was to add features to that old compiler? Let's see how JetPascal handles it.
This is just wild. Look at this comparison. To add something as basic as a for loop to a traditional compiler, you might have to change 500 lines of code across different files. In JetPascal, you write your new isolated wrapper for the for loop, and then you add exactly 1 line of code to the dispatcher to tell it that it exists. That's it. For something as huge as classes or generics, it's still just 1 line. It's unbelievable.
And this is the ultimate promise of this whole architecture. The core of your system stays simple, it stays stable, and it stays small forever. All the complexity is pushed out to these small, separate, easy-to-test pieces. You can scale the language up as much as you want without making the compiler itself more complicated.
So let's just zoom out for a second.
This is so much bigger than just a faster way to run old Pascal code. What we're looking at here is a blueprint for building any complex piece of software in a much, much better way.
So, who wins here? Well, Pascal developers get this massive performance boost without having to rewrite their code. People designing new languages, they get a proven recipe for how to build a compiler that won't turn into a God object monster. And performance engineers, they get to tap into decades of C++ and LLVM optimization basically for free. And that is the real takeaway. These ideas of isolating complexity, of keeping your core dead simple, and letting small, smart modules do all the heavy lifting, you can apply that to almost any big software project you can think of. This quote from the project's own documentation just says it all, doesn't it? It's this simple little mantra, but it's the absolute key to slaying the God object and building software that's powerful, fast, and most importantly, something you can actually maintain for years to come. And that leaves us with one last big thought. Just imagine. Imagine a world where adding a major new feature to a huge software project wasn't some high-stakes, risky operation, but a simple, clean, one-line change. The JetPascal project shows us that's not just a fantasy. It's an architectural choice we can all learn from.